Hey there! Turns out that I've had very serious bug in the previous lecture, the source code that I demonstrated in the previous lecture. And one of the students of this course, shout out to Andrew, thumbs up for being that skeptical and checking my code, found this bug, brought it to my attention. Now, at this point, I could just go back, edit the video, edit the source code, rebase something in Git, and no one will ever know about this mistake. But I don't want to do that. Instead, I want to record this additional lecture, explain to you where this bug comes from, how to solve it, and this will allow all of us to understand better, to deepen our understanding. And also this will show you that no matter how long you work with Android, some things like life cycles and state restoration, they will always caught you off guard sometimes. So let's understand what's going on. Alright, so that's my app, and currently you see the entire application that I've built throughout this entire course, but the previous lecture we just discussed state preservation. And what I told you that we implemented this mechanism that preserves the state of this circle over configuration changes, basically the position of this circle that we can drag around. But configuration changes are not the only situation when this activity will be destroyed. There's also something called process death in Android. And I call that save and restore because it's a more correct technical name. So save and restore flow. Before, so we send the application to the background. Now the app is in the background, but it's still alive and it still consumes memory. And Android can just decide, okay, I need more memory, so I will start killing these apps that reside in the background. And one of the candidates would be our application in the background. So let's say Android kills it. But before it kills the application and basically evicts everything from memory, it gives the app the chance to save its state. And then next time the user launches the app, Android will give it a chance to restore the state. So from user's perspective, a good application, well-behaving application should work as though there was no save and restore. It might introduce a little bit of delay, but generally speaking, user should land on the same screen in the same state. So how can we simulate this process of Android killing our application when it's in background? Well, there are multiple ways, but we will use one of the simplest ones. We will just search here for running services. And this is one of the entries inside developer options. So running services. And here I will go to these three dots, show cached processes. And you see this Android views master class. It's in the background, but it appears in this running services. I can click on it and let me just open the logcat so you could see what happens when I click on this stop. Okay, see, process ended for my application. So now the application was killed by Android. However, it wasn't just killed and will start from a clean state when I launch it the next time. It actually underwent save and restore. So the app got a chance to save its state. And then next time I launch it, it should undergo restore. But you see, process started, but then we scroll down, we have this exception and the app crashes immediately. That's the bug that Andrew found and pointed out that I have it. Okay, why this bug happens? Let's get back to this state preservation view. And here I remind you at the bottom, we implemented this on save instance state and on restore instance state to handle configuration changes. Turns out that basically the same callbacks are used when the app undergoes save and restore. And on save instance state is when you save your state, on restore instance state is when you restore the state. But due to some differences between save and restore and configuration changes, this bug did not reproduce during config changes, but it did crash the app during save and restore. So what's the problem here? Well, I don't want to go into too much details because it deals with parcel levels and parcels and how it's implemented, but at a very, very high level, notice how this write to parcel method is implemented. First of all, we call this super write to parcel, which, let's give it a moment to load the source code, writes some data into this parcel object. Now, so that's fine. Super writes some data and then we write data. But what happens when we create from parcel on restore? We just go and use this constructor, and then it immediately goes and reads this parcelable, which is supposed to be this super saved state. Now, there's a lot of problems here, but please notice that into this parcelable, when we wrote to parcel, first we roll this super data and only then our data. But here we immediately read our data from parcelable, from this parcel object. And that's a problem because before our data appears there are several entries related to this super class that put there. And therefore, when I just try to get this super state from this parcel, I get this null pointer exception because, well, this super state cannot be retrieved like that because there are other data coming first. So that's the problem, the implementation of this class. And as I told you, and as you will see later in this course in several lectures, I just copy paste blindly this thing, changing some parameters. So copy pasting works great when your code is correct, and it basically just reproduces the bug into multiple places when your code isn't correct. So what we will do right now is fixing this one single state preservation view, and I'll explain to you how to fix that. And then I will just go back, well, like for me, forward for you, I will just fix all the other instances where I used this approach and introduced this bug. And therefore, in the next lecture, some of them, you will see me kind of, repeating the same bug. Just remember that I already fixed it in the source code. So if you get the latest version of the source code, you should also get the fix as the latest commit. And if you haven't gotten it, then just do git pull to update your local branch. All right, what do we do here? Well, the problem is how we marshal this parcel and parcelables into this parcel object, right? And the problem is really here, the implementation of this constructor. Instead of doing this and then reading, just immediately these values from parcel, I should somehow let this super implementation read the values that it wrote right here. How can I do that? Well, there is, let's just go and, here, write to parcel. You see, it writes all this data. Let's see where, well, write int. Let's just look for read int, right? And here you see that you have this base saved state that receives parcel and class loader, and it reads this int. So basically, we need to somehow use this constructor or this one with just one single argument, and class loader can be null. And by the way, I noticed that here class loader can also be null, so I don't need to use any custom class loader. As the documentation says, if it is null, the default class loader will be used, and default class loader is totally fine by me. All right, now back to the problem. We need to somehow invoke the constructor that first reads the data that it wrote here into this write to parcel from this parcel object. How can we do that? Well, we'll do it the following way. Instead of invoking this constructor, we will invoke super and just, pass this parcel into this constructor. And then after we do that, we want to perform some additional actions inside this constructor of our circle saved state. What do we do here? Well, first of all, let's just move this into class level. Right, oh, sorry for that, I meant to do this. And then let's just change all of them to vals. And now what I want to do is do this super save state equals whatever I read from here. And this circle x center fraction, this, and y fraction, right, equals that. So what happens now is that we invoke this super parcel. And then after it goes and reads all the data that was written into this parcel before, we know that now our data, custom data, comes inside this parcel object, because parcel object basically just stores the data sequentially. So here we read our data after superclass read its own data, and this should be fine. But now we just need to change the implementation of this class. So first of all, we don't need to be data class anymore. We don't need a primary constructor here. We can get rid of this view. We don't really need this view, and we don't invoke constructor. Instead, what we do, we will create another constructor. I remind you that here we use this 3 arguments constructor, and we still need it. So let's go here and just create another constructor that will receive 3 arguments, these specific arguments. And again, let's just do it like this. and we don't need that. Okay, so 3 arguments, and it will delegate to super using this super saved state. Now here is a little bit tricky distinction between parcelable, which is a marker interface for parcelable objects, and parcel, which is a data structure that contains actual data. So you might notice that here I call super with parcel, which actually goes and extracts all of that. And in this constructor, I call super with parcelable, another constructor, which basically, if I remember correctly, doesn't do much. It just, saves the super state right here. Okay, so tricky distinction, but again, since we are going to copy paste this piece of code, you don't really need to understand in great details all about that. Just remember that parcelable is an interface, a marker interface for data that can be saved into parcel object. The parcel is the object that contains data. So here we just call this super and we say, hey, that's your parcelable object, do with it whatever you want. But now we have our own 3 properties which we want to initialize. So just like that, this x equals that circle x, and then this y equals circle y. All right, and now we have our class, which is not a data class anymore. It has 3 properties and it has 2 constructors. One constructor takes just the data right away and just initialize these properties, and another constructor takes a parcel object and extracts, after delegates to super in order for the super class to extract whatever data it put into this parcel before, and then extracts its own data from this parcel. And of course, this constructor is called by our code when we just want to save the data, right? Let's just see right here inside onSaved instance state. And this constructor is called from here when the framework gives this parcel object back to our view and says, hey, go restore your state. Right? And then we need to just basically extract our data, which was stored during save phase of save and restore. So during restore, we extract our data, and that's when we use this second form of this constructor that takes in parcel object. Okay, I think this should work. Let's just rerun the application and see, make sure that everything works. So state preservation, again, we have our circle. And if I just rotate the device, everything works. That's not surprising. It even worked before. What we want to check is now send the application to the background, go to settings, find these running services inside developer options, click on these 3 dots, show cached processes, find Android View Master Class or whatever you call your application, and click on stop. Anyways, now I want to launch this app, and you see that the process was started from scratch. We don't get any exception anymore. We land on this state preservation screen, and the location of our circle is just like before. And therefore, this means that the code that I wrote right now works. And as I told you, I will fix this code in all other places where I used this approach, where I saved state throughout this course. And therefore, please just remember when you see me writing the wrong code in the next demonstrations or next solutions to exercises, just remember that all of that has already been fixed inside the source code, and that's the correct approach. All right, that's it. Again, Andrew, thank you very much for bringing this issue to my attention. It allowed us to, well, see that you can always make these mistakes, and sometimes they're very tricky to find. It also allowed us to discuss save and restore state and see how we can simulate save and restore when we develop our applications. Now, save and restore is a very big topic. I have a course about Android lifecycles, and I discuss this topic in detail there. So here we just touched on this topic because Andrew found this bug, and I wanted to show you the solution. So we learned about save and restore, and of course we learned about how to properly save and restore the state of our custom views. And with that, I will see you in the next lecture.